and welcome back. In the previous episode, we took a look at a very cool piece of software that Gavin wrote called CCDP that let us pull the data off of one of these removable platters. All 5 megabytes of it. But we actually found some really cool stuff on these platters. Most notably, we found the operating system. We have the OS and it's bootable. So the next logical step was to spin the Hawk drive back up and boot into the operating system, and it wouldn't do it. We just kept getting read errors. So we're in this weird position where we have the operating system, we have it backed up, and I still don't know what it's like to actually use it. So that's what I want to do today. I want to try and get to a point where I can use the operating system, or at least see what it looks like on the terminal. But we're going to have to repair the Hawk drive first. Now, I think we have 2 issues going on. The first is pretty much isolated to the fixed platter. Every time we tried to pull the data off of the fixed platter, we would only get about 10 to 15 minutes of usable life out of the platter before it devolved into read errors. I'm pretty sure this is thermally related, because if I turn the drive off and then turn it back on again immediately, I keep getting those read errors. But if I turn it off and let it sit overnight to cool completely down, then I get my 10 to 15 minutes of usable life back. So probably we have a card in the card cage that's overheating, potentially because it's got a bad chip on it or something like that. So that's one thing that we're going to need to take a look at. But the operating system is actually stored on the removable platter, and it was reading totally fine until I spun the Hawk drive down and spun it back up again, at which point I was getting read errors again. And so what I think is happening here is actually more mechanical. Again, we don't have a head crash, so that's fantastic news, but whenever we spin the Hawk drive down, the voice coil pulls all the way back to unload the heads. And well, there's 2 little rubber bump stops between the voice coil and the magnet that prevent them from just doing metal on metal slamming into each other. And those have deteriorated over the last 40 years, and they're not there anymore. So every time I spin it down, it was just metal on metal, and that is enough of a shock, I think, to misalign the heads. Now, hopefully we can just put those rubber bump stops back in and then readjust the sectoring card that has a little potentiometer on it and get it back in spec without actually having to do a full-on head alignment. But there's no real way to know until we get the new rubber bump stops in and the new cards in and start giving it a test. So let's hop over to the machine and get to work. We got a lot to do. All right, first things first, let's slide the Hawk drive all the way out. Then I need to pull the cotter pin off the side of the magnet here and use that to lock the heads in place to ensure they don't accidentally hit the platters. And then I will unplug everything from the servo preamp board, remove the 4 screws, and then the preamp board can come right off, giving access to the voice coil underneath. Now next we need to remove the velocity transducer. There's a little safety cover on the back, so we need to remove that. And then the transducer is held in place with a little lock screw, and with that loosened up, it slides right out the back of the magnet, though the magnet can tend to grab a hold of it. Next, there are 2 screws on the bottom of the magnet that we need to loosen up, and with both of those screws out of the way, the entire magnet slides right off. And this is where the rubber bumpers are. You can see that on the one that we removed here, the rubber bumpers are completely gone. It's just metal. And here is a replacement magnet that I pulled from one of the other Hawks, and it actually has good rubber bumpers on it. It actually looks like they may have been replaced at some point in time. These are nice and squishy still. So now we just reverse the process. We slide the new magnet in place, we cinch it down with the screws, we slide the velocity transducer back in, then the servo preamp board goes back on top, we plug everything back in, and that leads us to the next thing, which is I want to replace the sector board. And this may not be necessary, but it's easy to get to, and I have spares from the other Hawk drives. So I just pop the boards out of this Hawk drive and the spare card cages, swap them around, push everything back in place, and we're good to go. Except one last thing that I want to check is the grounding lug on the bottom of the drive. So once I get the cover out of the way, we can see that the lug here has seen quite a lot of use, and this much wear can cause essentially a bad ground connection. So I'm just going to use a little bit of sandpaper to clean it up, make sure it's making a good connection here. Now before we actually spin it up, we want to purge it just in case I've shaken any dust loose. So we're going to flip the breakers on the back, press the button on the front to spin it up. And while we're waiting for it to purge, I think it's time to have a little bit of homemade bread from Mrs. Usagi Electric. And of course, I'm gonna put a little bit of homemade strawberry jam, again from Mrs. Usagi Electric, right on top of it. And y'all don't need to see me eat. All right, now that my stomach is full and we've been purging the drive for a while, it's time to get the diag card set up to the Hawk read test. Then we need to hook the head actuator back up, and we need to spin the drive up and wait for it to load the heads. And then it's time to get it to try and pass the read test, and well, I'm still getting read errors, unfortunately. So I worked on this way too late into the night last night, and I didn't get anywhere. No matter how I adjusted the sector potentiometer, I could not get it to pass a read test, which is not good. So I got in touch with Ken Romaine, and he started walking me through how to use the test operating system to kind of peek and poke the Hawk drive itself so that we could maybe get an idea of what's going wrong. And well, the long and short of it is that I'm pretty sure we've got a misaligned head, which is not good. That means we're going to need to do a head alignment, which is going to require a bunch of special equipment that I just don't have. But the reason that we were able to come to that conclusion is because the Hawk has a status register that we can read through the test operating system on the diag card. So let me show you guys exactly what the status that we're seeing is and what that means and how we kind of came to the conclusion of having a misaligned head. So let's take a look at TOS right quick and I'll show you what I mean. All right, so the entire MMIO space for the Hawk drive is in the F140 range. So we'll start with MF140. This is unit select. So we'll set it to 00. That's going to be drive 0, platter 0. Platter 0 is going to be the removable platter. Next, MF141 and 142 are the address. So we're going to set that to 0000. Now it's a little confusing how this is laid out. You have to actually look at the binary. The first 11 bits are the cylinder, then there is 1 bit for the head, and then 4 bits for the sector. So 0000 selects cylinder 0, head 0, which is the upper head, and sector 0. Now next we need to issue some commands to the drive to tell it to seek to this address and read from it. So we're going to start with MF148. That is the MMIO for controlling the drive. And we'll send it a command of 03. This is an RTZ command. Yeah, I heard it go ka-chunk. Then we'll do 148 again. And we'll do 02. This is to tell it to seek to this address. And then we do MF14800. This is telling it to read from where it is currently at. And then we'll hit that. And now we need to read the status of the Hawk drive. And the status is stored in F144 and 145. 144 space. We can see that we get 00B0. Now F145, which is at B0, means that it just has write protect on. That's good. 144, which is currently at 00, is telling us that there's no errors. Now, there's a lot more meaning behind what's going on here, but for all we care about, 00 is good news. So that's telling us that the upper head is reading correctly. Now let's take a look at the lower head. So we got to do essentially this entire thing over again. So we'll go MF141 and we'll leave that as 00, and then we'll change it to 10. And that is going to select the lower head. And then we need to do our RTZ, our seek, and our read. And so now we're ready to actually look at the status registers again. So MF144 space. You can see now we've got 20B0. Should be 00B0, but since we've got a 20, that tells us that we've got an error on the lower head. Now 20 is telling us that we have an address error. Through all of the different testing we've been doing, we sometimes come up with a 10, which means a sector format error, but we really want to be seeing 00s. So this is telling us that our lower head is not reading correctly. Now there's actually a much better way of demonstrating this using CCDP. So let's go ahead and get into CCDP. And I already punched in the bootloader, which is at M01E8 here. So we'll just tell it to go to 01E8 and execute that code. We get our little et symbol. We'll do 32k.sys, hit enter. And there we go. We've loaded up CCDP. That looks just amazing every time I do it. So we'll do a directory listing here, and we can see that we have right here HWKREA. This is a little piece of software that Gavin knocked up for me to help make it a little bit easier to see what's going on. So we'll go ahead and punch that in. We'll get it started here. So it's asking me the unit. We're going to say 0. It's telling me what cylinder to read. We'll tell it cylinder 0000. It's return to 0 on error. No, we don't want to do that. Ready to begin. Yes. Hit enter. And here we go. It's reading cylinder 0000 over and over again. And a dot is a successful read and an X is an unsuccessful read. And so you can see split right down the middle here, we have a very clear division between successful reads and unsuccessful reads. And well, the way that this is laid out is it reads 16 sectors of the cylinder using the upper head, then it flips to the lower head and reads the next 16 sectors. So you can see that the upper head is reading just fine and the lower head is not. However, it's not all perfect. If I hit space to exit out of this, we will run that program again. Okay, so we want unit 0, and this time I'm going to test cylinder 1. So we'll do 0001. I will hit enter, RTZ on error, no, ready to begin, yes. And now you can see that we're getting read errors on cylinder 1. So cylinder 0 was reading perfectly, but cylinder 1 is reading consistently bad. And this is very strange behavior, especially if we take a look at a different cylinder much deeper. So again, we'll run it one more time. Unit 0, cylinder 00FF. This is much deeper into the platter, and so we should see errors or reads or something. So let's start this one, and it is seeking up to that cylinder 00FF. And well, that's interesting as well. You can see that we have one sector that is consistently getting a read error, but the rest are reading fine. So what this is telling me is that the upper head is just barely out of alignment. And depending on the cylinder that I'm at, we either get clean reads or we don't. But it's also telling me that the lower head is out of alignment no matter what we do. So we're going to have to do a head alignment on both heads, which is unfortunate. Usually to align the heads, you need a lot of very custom equipment. Most notably, you need a CE alignment pack. This pack has a very specific analog pattern at a very specific location. And you hook an oscilloscope up to a specific test point, you spin the drive up, fly the heads out to that specific location, and you can see a very unique pattern on the scope. And then you adjust the heads to make sure that you get this, what they call cat's eye pattern, looking just right. However, I don't have the CE pack, and without this, normally a head alignment would be nearly impossible. But we have CCDP, and with Gavin's program, we can read the same cylinder over and over again, telling us if we got a successful read out of it or a bad read out of it. However, even with Gavin's program, we still need a tool to physically move the heads for the adjustment. And Ken actually remembers using a tool for this, So he drew up this diagram based on his memory of the tool, and I went out to the very dead hawk that we have and took some measurements and got to work, starting with this large chunk of aluminum. And I need to get this specific shape out of it. So I first describe where I need to cut, then I start machining away aluminum in small chunks. Once I'm pretty happy with the shape and how it's coming together, I take a bigger chunk out to get the final cut out. Now next I need to machine the little slot in the front, and I use a small bit here and I take little bites, but I got a little impatient and yeah, that's a broken bit. Oops. All right, let's try again. Yeah, all right, there we go. That's much better. So next we need to drill a hole for the roll pin. And the roll pin is actually just a nail with one end flattened. So I just hammer that into place, and once it's in place, I will shorten it up to the right size with the angle grinder here. Next, a little bit of sanding to clean it all up, and then a little bit of polishing to make it smooth. And here's the finished tool. We put some heat shrink on the handle so we don't short anything out while using it. Now to use this tool to adjust the position of the heads, the first thing is that we loosen up the locking screw here. Then we engage the tool with this vertical bar, and the roll pin slots into the cutout in the head arm. Then the location of the fulcrum point to the roll pin and the fulcrum point to the end of the tool allows me to essentially move the back end of the tool several inches to move the roll pin just thousands of inches at a time. This allows for very precise positioning of the heads. So with Gavin's tool fired up, we started the process of adjusting the heads, and it took a little while to get a feel for it. But once I got it, it was extremely easy to adjust the heads and turn the X's into dots, turn bad reads into good reads. And it's looking pretty good, but I want to double check that we're still good on a different cylinder, and yep, absolute victory. All right, well that worked like gangbusters. I can't believe how easy it was to align the heads. That was something that I had been dreading forever, but Gavin's program with the constant streaming of the cylinder showing us how we were reading just made it so easy. We could adjust it in and out of the reading area, and we just put it in the middle and we had perfect reads. Not only that, we did a head alignment for the fixed platter as well. So what I think was happening with that was that it was already misaligned pretty much extremely so. And then whenever we spun it down, that metal on metal contact just pushed it even further. And now we've got it lined up, and Gavin's program was showing perfect reads on the fixed platter. So, you know, I said I think we had a thermal issue on it. I think that thermal issue was actually the platter itself thermally expanding and pushing the heads out of alignment. But now it looks like it's perfect. So the next obvious step is to try and boot into the operating system, which is what we've been trying to do for the last 4 days. So I've got it turned on right now. The hawk drive is not spun up yet, but I'm sitting at the D equals prompt. So all I gotta do is spin the hawk drive up and then tell it to boot off of the removable platter, because we know there's an OS on there. So let's do it. Let's spin the hawk drive up and give it a go. The hawk is spun up, the computer is booted, waiting for me to tell it what drive to boot from. We know the removable platter has an OS on it, so we'll do hawk platter 0. I heard it do a whack, 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 which is what it's supposed to do. Should be loading the OS now, but we seem to be stuck somewhere. That's interesting. It says ATT in print. All right, that's a new one. We haven't seen that one before. So this is going to require some additional troubleshooting. We've gotten further than we've ever gotten before. We got to a point where we're printing ATT in print on the terminal, and I've never seen that before until this moment. Well, I say this moment, there is a bit of a time lag between the takes here, and I've actually been talking to some of the people on the Discord, and they've been digging through the operating system code that we dumped off of the removable platter, and we are like 95% certain that this error message is coming from within the operating system, which means that when I typed H0, the Whipple loaded, then looked for the file called /load. It loaded that up, executed it. It got all the way into the operating system, and then it ran into whatever this problem is. Now, we have some ideas about what this problem might be, but you know what? I'm not even going to tackle that today. We're very close, and I'm going to get into it soon, but we got the hawk drive going. We adjusted the heads on both the removable platter and the fixed platter. And that's something that should have required thousands of dollars of custom tools, and we got it to work with Gavin's amazing program. This is such a huge victory, and we are so close to that finish line, and we're gonna try and cross that finish line in the very next episode. So I wanna thank you guys so much for joining me today on the hawk drive repair, and I hope to see you next week, because the very next episode is gonna be us trying to get into the full operating system, even though we're pretty close to being there already. So thank you so much, and I hope to see you next time.